Hello friends, welcome to today's lecture column. Myself, Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yatra. So in this lecture, we discuss about column. Column is a vertical structural member subjected to axial compressive load. Basically, there are two members, that is column and strut. Column is a perfectly vertical member subjected to axial load or compressive force, and strut is an inclined member subjected to compressive load. This is the difference between column and strut. Then failure of column. Failure of column, it depends upon the failure pattern or that stresses induced in the column. That is, first is direct compressive stress, second one is a buckling stress, and third one is combined direct and buckling stress. Means these three types is a types of failure of the column. Direct compressive stress means when you consider a short column means as compared to length, dimensions are means lateral dimension of the section is less, that column called as short column. So that failure pattern is crushing. When you apply load on the column, the failure or that failure pattern is crushing, that called as direct compressive. Buckling stress or buckling failure, it means the length of the column is more than the with respect to its lateral dimension, so it fails due to buckle. And combined and direct and buckling stress means the combination of these two, means direct compression and buckling. So for analysis of column, basically two theories are there. First one is Euler's column theory and second one is Rankine's column theory. In this lecture, we discuss about Euler's column theory. So basically, before starting this theory, some assumptions are there for this particular Euler's column theory. What are those assumptions? Let us see. The column is initially perfectly straight and the load is applied axially. Means this theory is applicable or this theory is considered only when the column is perfectly straight and the load applied on that column is totally axially. Axially means the load passes through its CG of the section. Then second is the cross section of the column is uniform throughout its length. Means this theory is applicable for only when the cross section of the column is same for throughout the length. Means this theory is not applicable or this limitation for this theory when our column is varying cross sectional area. Then third is the column is material perfectly elastic, homogeneous, anisotropic and obey Hooke's law. Means the material for the column is perfectly elastic, homogeneous and isotropic. Means the property of the material at each and every point remains same and is obey Hooke's law. Fourth one, the length of the column is very large as compared to the lateral dimension. Means already we discussed this theory is applicable only for long column. When you this theory or calculate this load by using this theory is right when the length is as compared to lateral dimension is more. Then fifth, the direct stress is very small as compared to the bending stress. Means due to its large length, the failure pattern will be in buckling. So direct stress automatically produced or induced in the section is less as compared to the bending stress. Then sixth, the column will fail by buckling only. Means the failure pattern is only buckles. In this theory, we consider only buckling pattern, not consider as a crushing. And last one, the self weight of the column is negligible. Means whatever the load comes, external applied loads, only that load is considered. the internal or self weight of the load is negligible. This is the assumptions made in Euler's column theory. So before starting the Euler's formula or Euler's equation, we know some end conditions of the column. Basically, the column are four end conditions. First one is both ends are hinged or pinned. This is the first condition. Sorry, this is the first condition for the end condition, that is both ends are hinged. This is number one. Both end hinged means or pinned. The effective length of the section of the column is L effective is equal to L. Means this is L is the actual length. Means when the both ends are hinged, our L effective will be L. Then second one is one end is fixed and other end is free. So this is the second condition. One end is fixed and other end is free. So at that condition, effective length will be L effective is equal to 2L. Means effective length is equal to 2 times into actual length. Third condition is both end fixed. So this is our third condition. Both ends are fixed. When both ends are fixed, L effective will be L by 2. Means L effective is equal to L actual divided by 2. And fourth condition is one end is fixed and other end is hinged. This is our fourth condition. One end is fixed and other end is hinged. So L effective is equal to L by root 2. Means L effective is equal to L actual divided by root 2. These are the four conditions. These four conditions is used for the calculating effective length. Once again I repeat, if both ends are hinged, L effective will be L. If one end is fixed, other end is free, then L effective is equal to 2L. Both end fixed, L effective is equal to L by 2. And one end fixed and other end hinged, L effective will be L by root 2. These four end conditions are most important for analysis of column. So Euler's equation is equal, P is equal to pi square EI upon L effective square. See here, this is the L effective, not just only L. This is the effective length. P is equal to pi square EI upon L effective square, where P is equal to Euler's crippling load. Whatever the load you got by using this equation, that is a crippling load. Crippling load means at the time of the failure. So P is equal to Euler's crippling load. A is equal to cross sectional area. Then L effective is equal to, L is equal to L effective, that is effective length. Then I is equal to least moment of inertia. Whenever you consider any section, you have know the two moment of inertia, that is Ixx and Iyy. Then which moment of inertia is used in this equation? So use least moment of inertia. Least moment of inertia means compare Ixx and Iyy, and whichever is less moment of inertia in the Ixx and Iyy, consider that moment of inertia in this Euler's equation. Then E is equal to modulus of elasticity. So this is the Euler's equation. Once again, P is equal to pi square EI upon L effective square. See here, pi is a constant, E is a material property. Just only we need to calculate moment of inertia and effective length. Effective length depends upon the end conditions, and moment we need to calculate only moment of inertia. And moment of inertia is used least moment of inertia, that is we want to calculate Ixx and Iyy, and comparing Ixx and Iyy we need consider minimum moment of inertia. Means when you analyze the column, the most important thing is moment of inertia I. So let us see one problem. A solid round bar 3 meter long and 50 mm in diameter is used as a strut with both ends hinged. Determine the crippling load. Take E is equal to 200 into 10 raised to 3 Newton per mm square. So basically a round bar means that is the circular section and length of the bar is 3 meter and end conditions are both ends are hinged. So basically I is equal to moment of inertia for circular section is 5 by 4 into d raised to 4. So d is a 50, 5 by 4 into 50 raised to 4. The moment of inertia is 30.68 into 10 raised to 4 mm raised to 4. Due to the circular cross section, the moment of inertia, that is Ixx and Iyy, both are same. So Ixx, Iyy is equal to, that is I minimum. So directly use this 30.68 into 10 raised to 4 as a least moment of inertia, that is I minimum. Then we know the end conditions that mentioned in the problem, that both ends are hinged. For both ends are hinged, effective length, that is L effective, is equal to L actual, means L is equal to 3000 mm. Then we know the Euler's equation, that is P is equal to pi square EI upon L effective square. Pi E value is given, that is 200 into 10 raised to 3 Newton per mm square. Then I is equal to 30.68 into 10 raised to 4. Then L effective square, that is L effective is 3000 square. By calculating this all, by solving this equation, we got P is equal to 67.288 into 10 raised to 3 Newton or 67.28 kilo Newton. This is a solution for a simple problem of column by using Euler's equation. Thank you.